The James Webb Space Telescope has recently astonished the scientific world and sparked global intrigue by identifying something that stretches the limits of our current cosmic understanding. Drifting silently in the vast expanse of space, its golden mirrors unfurled and collecting light from realms billions of years old. The telescope has detected something so cold, so entirely devoid of heat, that it challenges our fundamental assumptions about the universe's thermal nature. This isn't just a chilly corner of space. It's something far deeper. It's as though the telescope peered into the darkness and uncovered a part of the cosmos that time and energy abandoned. The discovery is so strange, so unsettling, that it has figuratively frozen the scientific community in awe. What lies at the core of this revelation is not simply the extreme cold Webb detected, but where it was found and what it might mean. Scientists aimed the telescope at a distant galaxy cluster, older than any previously studied. Hidden deep within, obscured by interstellar dust and distorted by gravitational lensing, was a region with temperatures just fractions above absolute 0-273.15 degrees Celsius, the theoretical limit at which atomic motion essentially stops. What makes this so stunning is that such a region wasn't thought to be possible, not at this level of cold, not in such a lifeless state, and certainly not this early in the life of the universe. In all known models of cosmic evolution, energy flows throughout space even in its emptiest parts. The cosmic microwave background radiation, the Big Bang's residual glow, permeates the universe at a near uniform to 0.7 Kelvin. Yet Webb identified an area where the temperature dropped even below this threshold, contradicting our current understanding of how heat disperses through space. It's as if one walked into a room that should, by every blueprint and principle, contain heat only to find it completely absent. What Webb discovered was not just a void, but something functioning like a vast cosmic freezer, immense, ancient, and utterly still. Initial reactions ranged from shock to deep curiosity. The data was reviewed, tested, and cross-examined by independent teams. This cold region wasn't a miscalculation. The numbers were consistent. Spectroscopic studies showed that molecular movement in this region was slower than anything previously observed at that distance. Infrared scans confirmed thermal readings well below anticipated levels. This wasn't an anomaly, it was a revelation, a shift in how we understand the universe itself. One emerging theory is that Webb might have found remnants of a structure that predates the Big Bang. If so, it would be an extraordinary possibility. The idea that something could exist before the universe as we know it, that there may be ancient structures woven into the fabric of space-time, could overturn foundational ideas in modern physics. For decades, physicists have speculated about a multiverse, alternate dimensions, or a cyclic universe. But this is the first time physical data has strongly hinted at something existing beyond or before our known cosmic timeline. If this ultra-cold region is indeed a leftover from an earlier phase of the cosmos, it could support theories in which the universe repeatedly expands and contracts, dying and being reborn over and over. What Webb may have captured is a fossil from a previous universe embedded in the fabric of our own. Such a possibility propels what was once fringe theoretical speculation into the spotlight, driven not by imagination, but by hard data. Another idea gaining traction is that this region may contain an unusually dense concentration of dark matter acting in unexpected ways. Dark matter, which makes up about 27% of the universe, doesn't emit light and interacts weakly with ordinary matter. Some scientists suggest it may also possess unknown thermal properties. If this area is saturated with a type of dark matter that drains surrounding heat or absorbs cosmic background radiation, it could function as a kind of cosmic sponge pulling warm from everything around it. In that case, the region wouldn't just be cold because it lacks heat, but because it's actively removing it. That would mean our understanding of dark matter is incomplete, perhaps even flawed. Webb's findings could force a major revision of what we think we know about this invisible material. If dark matter can dramatically alter thermal behavior under certain conditions, it might mean that entire regions of the universe once dismissed as inactive are hiding complex, unseen physical phenomena. This chilling discovery may be the first tangible evidence of deeper cosmic layers we've never accessed before. There's also the provocative idea of dimensional overlap. Some physicists propose that if other dimensions exist alongside ours, they may occasionally interact or imprint upon each other. The freezing anomaly Webb detected could be the trace of such a crossover and extra-dimensional cold front that leaked into our universe and left behind a frozen imprint. It's a wild idea. But when faced with unexplained evidence, science must stay open to even the most unconventional explanations. Beyond its scientific implications, this discovery carries immense philosophical weight. For most of history, we've viewed the cosmos as a realm of stars and heat, a glowing furnace in the sky. Even the coldness of space was understood as relative, filled with the faint radiation of distant origins. Now, with this latest glimpse into the void, we're confronted with the idea that some regions of the universe aren't just cold, they seem to reject heat entirely. Here, time might nearly stand still, atomic motion slows almost to a halt. Thermodynamic principles, once thought universal, appear suspended. It's not just the absence of energy, it's the presence of something far stranger, a cosmic stillness whispering secrets from a time before time itself. That alone is enough to shake even the most experienced scientists. This discovery is already prompting a rethinking of how we design and use telescopes. Instruments are being recalibrated. Missions are being reimagined. Webb has shown it's not just a viewer of distant stars, it's a light in the darkness, revealing hidden landscapes once thought inaccessible. Scientists are now exploring the possibility that these cold zones may not be rare, but widespread part of a colder cosmic architecture we're only now beginning to detect. Webb, with its unprecedented sensitivity, may have only scratched the surface. There's something hauntingly beautiful in the fact that our most advanced tool built to see the birth of time has instead uncovered something possibly older or beyond our concept of time. A lens meant to capture history may have revealed a crack in the very structure of reality. The psychological impact of this cannot be overstated. Humanity has always looked to the stars for inspiration, warmth, and wonder. Yet this new evidence reminds us that the universe is not only about brilliance and fire. It is also about silence and frost, and in that silence may lie truths deeper than any beam of light can carry, stories forgotten, forces dormant, or cosmic messages only now starting to emerge from their icy slumber. This isn't an ending. It's a beginning, the opening line of a story filled with mystery, depth, and possibly a new understanding of existence. This is the kind of moment that makes us pause, reconsider, and look into the cosmos with new eyes, not with fear, but with awe. The world stands still, not from dread, but from pure cosmic wonder. Webb has peered into a place where he should reside, and found none, reminding us that the universe is larger, stranger, and colder than we ever dared believe. There are no conclusions, yet only more questions, more possibilities, and a renewed sense that we are still beginners, learning to swim in a vast ocean of the unknown. This discovery is unfolding with implications that grow more astonishing with every new image and data set. What's extraordinary isn't just that Webb found a cold region, it's that this kind of cold doesn't follow the rules of known physics. It behaves as though it belongs to a separate reality, a hidden realm quietly coexisting with everything we think we understand. Further analysis reveals that this frigid region isn't uniform. Within it are patterns, subtle arrangements of matter and radiation suggesting deliberate structure. Threads, clusters, filaments so faint they would escape less sensitive instruments, but now visible through Webb's powerful infrared imaging. These aren't natural formations. They don't resemble typical gas clouds, gravitational clusters, or any known product of standard thermodynamic cooling. Their alignment is too precise, like the fossilized remains of something that once lived, once burned with heat, and then simply stopped. This raises the possibility of thermodynamic manipulation on a cosmic scale. In physics, entropy is the tendency toward disorder. Energy spreads out, stars die, atoms drift apart. Yet what Webb found may represent a form of entropy control, a place where this natural trend was arrested, something resisted the heat death of the universe and left behind an icy scar that suggests intervention, not necessarily life, but agency, a mechanism or process that acted against the usual flow of thermodynamics. Scientists are now calling it a thermodynamic null zone, a term for areas where the ordinary behavior of heat is disrupted or reversed. Until now, this was only theoretical. Webb's observation marks the first real evidence of such a place. It